So now we're going to look at this one. Same thing. We need to decide if this converges or diverges. So we're going to look at the limit. So we have the limit as n approaches infinity of the absolute value of. So we have n plus 1 on top. We have n on bottom, so I'm going to literally rewrite what we had. So now all I'm going to do is take everything that I have there and do an n plus 1. So I have n plus 1 squared, 2 to the n plus 1. I have 3 to the n plus 1. And just like before, we're going to go ahead and multiply by the reciprocal. So n plus 1 squared, 2 to the n plus 1, 3 to the n plus 1, times 3 to the n over n squared 2. Yep, that's where I was wrong. So right here, we already have n plus 1. So we need to do n plus 1 plus 1. So instead of n plus 1, we're now looking at the n plus 2. So we have 2 to the n plus 1 over here because it's our original function. Okay, I'm going to separate this into a couple different things. So I have the limit as n approaches infinity of the absolute value of. We have n plus 1 squared over n squared times 2 to the n plus 2 over 2 to the n plus 1 times 3 to the n over 3 to the n plus 1. Okay. We're going to go ahead and leave n plus 1 squared over n squared. And we're going to simplify the other pieces here to kind of make it a little bit easier. We can kind of leave that one because they are polynomials. N squared is on top and bottom if we were to multiply out the top. So it's a little bit easier to kind of deal with. We have 2 to the n plus 2, and we are dividing it by 2 to the n plus 1. I can do something similar. I can take away 1 from 2 to the n plus 2 and make it 2 to the n plus 1 times 2 to the n, or 2 to the 1. And so when I divide these, I can subtract those exponents. N plus 2 minus n plus 1 would give us 2 to the first. 3 to the n divided by 3 to the n plus 1. Same kind of deal, except for we're going to have 1 over 3, so 1/3. So right now we have 2/3 times this thing here. This would look something like the absolute value of 2 times n plus 1 squared divided by 3 n squared. And if we look at this, this would be an EHDC. Its exponents are the same, so we're going to divide the coefficients. Our degrees are traveling at the same rate. So we divide the coefficients, which in this case would be 2/3. 2/3 is less than 1. So we know that we are going to converge. By the ratio test.